Hello guys, today I'm going to talk about the speed control of induction motor. Uh, Firstly, to talk about the induction motors. Induction motors are typically a constant speed motor. A constant speed means minimum speed variation with load uh, in relative to total loading level. In contrast, the speed of the decision system can be easily adjusted. Uh, with high efficiency. Speed variations in induction motors results in considerable efficiency loss, a reduction of power factor. And induction motors are widely used in many applications. And speed control critical due to constant speed nature. What this means is the speed control in induction motors is a critical consideration due to their constant speed nature. And the relationship between synchronous speed, rotor speed and slip is given by the formula S is equal to ns minus n divided by ns, where n, the rotor speed, is given by ns times 1 minus s. Ns is the synchronous speed, which is given by 120 f by p. And after substituting 120 f by p in the above formula, we get the formula n is equal to 120 f by p 1 minus s. From this equation, we can see that the speed of the rotor or the speed of the induction motor can be varied by varying frequency, pole and slip. And the speed of the induction motor can be controlled in 4 various methods. Firstly, by changing the applied voltage. Second, by changing the supply voltage. Third, adding rheostat in stator circuit, and by changing number of poles. Firstly, I'm going to talk about by changing the applied voltage. And according to torque formula of induction motor, the torque formula is given by the formula K as E2 square R2 divided by root of R square plus X2 whole square. R square is basically fixed, and if the slip value S is quite small, the term X2 whole square is so small that it can be neglected and can be removed. So by looking at this formula, we can see that torque is related to S E2 square. E2 is basically the induced EMF in rotor, where E2 is directly proportional to the applied voltage. Therefore, the torque can be based on SV2. SE2 can be same as writing as V2, which means if the required voltage is reduced, the final torque drops, E2. Hence the slip rises due to supply the same load torque with a reduction in voltage, and as a result speed decreases. This method is too simple and effective, but rarely employed because large variation in voltage output is needed for relative few changes in velocity. This is how the circuit will look like by changing the applied voltage. And second, to talk about by changing the supply frequency. Here, from the formula we derived earlier, we can see that the frequency, by changing the frequency, the speed of the rotor can be changed. The synchronous speed of the moving magnetic field in an induction motor can be calculated by the formula Ns is equal to 120 F divided by P, which is calculated in RPM, where F is the frequency of the system and P is the number of poles in the stator. So basically, from this equation we can see that the speed of the rotor can be changed or varied with frequency. And thirdly, to talk about adding rheostat in stator circuit. Here in the stator side, it is seen that the rheostat is added to the circuit. We have seen that the reduced voltage can be applied to the stator by adding rheostat in the stator circuit. What it means that by applying adding rheostat in the stator circuit, we can reduce the voltage, which in turn reduces the speeds. The arrangement is shown in figure. The part of the voltage gets dropped across the resistance. The reduction in stator voltage causes reduction in speed. Basically, the first thing I said, the rheostat can be varied as per the required change in speed, but the entire line current flows through the rheostat and hence there are large power losses. This method is not efficient from speed control point of view, hence used as a starter rather than as a speed control method. That's it for the day. Thank you.